Good afternoon. Today's recording is going to be focused on using a multi-cluster Kubernetes environment with CIS and BIG-IP. So that's quite an interesting topic, and there are quite a lot of changes that needs to happen to actually get this environment working, specifically with BIG-IP using a Flannel environment, vxlan environment. Now, why would somebody want to set up a multi-cluster with Ingress using BIG-IP? And organizations today are increasing their deployments, and I am seeing more and more organizations wanting to create multiple clusters, or in this case, multi-cluster type of environment. One of the reasons potentially is the progression or improvement of availability and potentially to do isolated testing. So the promotion of an application from, let's say, dev stage to production, or if you want to just do development and production. It also helps to scale the environment better to do development of your, if you want to call it, pods, or make sure those pods are ready and then move them into production. It is best practices to use a dedicated BIG-IP for a dedicated environment. However, sometimes that might not be what you have, and somehow maybe you want to really ask yourself, is it okay, potentially, in my example right here, to have a BIG-IP servicing a dev cluster as well as a production cluster? Again, recommendation and best practice, of course, is to have a dedicated BIG-IP for production cluster as well as for dev cluster. But in this example, I want to show you what I've done and allow you to give this a try. So again, my repo, you can clone it, you can pull in the files that you need, and you can then go ahead, make the changes, follow my user guide, make the required changes, and then go ahead and implement this. So what's really important here is that the application is the same. So this F5 service is deployed basically in two clusters. These are two unique clusters. They really don't know about each other. The only thing that knows about the two clusters is the BIG-IP. And in these unique clusters, we have a dedicated CIS and a dedicated IPAM controller. And CIS is communicating with the IPAM controller to provide IP management specifically for this cluster. What's really important here is the networking between the two clusters are different. The networking has to be different, and therefore the VNIs are different, since I'm using Flannel in this environment. So the dev cluster, I used a default environment of the VNI1 with the default Flannel networking. Pretty simple to configure. There's no modifications that you really need to make when you're deploying Flannel using all the defaults. And it is really simple to configure Kubernetes with Flannel using default. Basically, you have to just pull in one configuration file, and you're pretty much done, and you're off. Your networking is complete. It is really truly simple. It's a little bit trickier on the BIG-IP because there are things that you have to do. You have to create the vxlan tunnel, you have to create the self IP, and you have to understand this concept of Flannel network and Flannel subnet. Now, here comes the challenge. What happens if I want to create multiple vxlan profiles on BIG-IP? And that's the question that I have been getting asked by a lot of the sales organization that work for F5, as well as the community over Slack and GitHub. How can I create multiple tunnels on BIG-IP with different VNIs? And so that's what I want to demonstrate. You will notice that the production cluster has a different Flannel network. This Flannel network of 10.245. This is not the default, and this is also not the default VNI. So what's really important is that when you read through this guide and when you deploy this second cluster, when you configure the Flannel networking, is when you have to make the modifications. And I've spent significant amount of time working with development to research this and provide this user guide so that you can accelerate your deployment. So let's go and take a look at the first configuration that you would be required to do. So the first configuration is, of course, using kubeadm to configure the Flannel environments. And as you can see here on my development, with my development CIDR, and of course my production CIDR. So this is a standard, I'm using standard kubeadm build tools here with the appropriate network CIDR information. However, here's the challenge. In the production Kubernetes cluster, even though I use kubeadm init with the correct network information, it actually doesn't work. It actually creates the default, and of course that's not going to work. So you have to actually go in and actually edit this kubeflannel.configuration. It's a simple config map. So by going in and making the change manually is the only workaround that you have. How do I know this? I worked with the Flannel developers within the community over the last couple days to actually get this working. And so it was very frustrating because I was configuring it and I wasn't able to make this work. And so when I worked with them, they said, yeah, it's potentially a bug, but in any case, the workaround is to go manually update it. So once you've configured it, you have to go manually change the network, the base network. And what you also have to do is add the VNI. The VNI is not there. So you have to add the VNI manually. Here's the thing. It does require a Kubernetes cluster reboot. So you can reboot it. I did that. Reboot the nodes, then reboot the master. Everything comes back up. And what you can actually do is at this point you can actually take a look at the Flannel environment, and you will notice now that the changes are actually correct. And so that's one aspect. You still haven't finished. You have to go and edit the Kubernetes nodes to add the second backend information. As you can see, there is the VNI 11 with the VTIP information. You have to do this for all of your nodes. So in my case, it's a 3 cluster node. It's 1 master and 2 worker nodes. I have to make this change into all of those. I also have to make this change in the dummy node. The dummy node is for CIS to use for its networking. It creates this dummy node. We call it the BIG-IP node. You have to make sure that that VNI is correct. And you will see that here. So the one last item before we do this, before we move forward with the actual demo, is on BIG-IP, you need to create the vxlan tunnels. And so this is actually not that complex. If you kind of follow my logic, I've given you the TMSH commands to do this. What's really important here is that you cannot create the vxlan tunnels in common. And that's the way, because CIS writes to the BIG-IP, it will start to get confused even though it has a name of the tunnel. So the name of the tunnel is really important. The name of the tunnel is called vxlan tunnel dev and vxlan tunnel prod. So let's go take a look at the BIG-IP. And so what we'll do is we will change this to dev, and we'll go down to the tunnels, and we'll take a look at the tunnel first. And you can see what I've done is I've created a vxlan tunnel. That is the name of the tunnel. This is the name that is going to be reflected as the profile name in the CIS controller. And you can see this is just a profile name that I created. It's just a very simple profile name that I first created. You will see in my diagram, that's really the first guide that I used. And you can create this for both the dev tunnel as well as the prod tunnel. This just basically says I'm going to use vxlan. It is of a flood type none, and I'm using the following port. And that's fine. That you only have to use once, because you're going to refer to it again in the later sequential commands. And so by doing this, you are creating a dev tunnel as well as a prod tunnel. And so you can see there's the two tunnels. Now if we select on the tunnel, you're actually going to see the profile that was actually created. This was from that very simple command. But what you should also see, there's the magic. These are forward database entries. These forward database entries are gathered by CIS. CIS is learning these forward database entries and configuring the BIG-IP with their associated forward database entries. If you don't have forward database entries, you're not going to make any progress. Simply, you won't be able to reach the pod network from BIG-IP itself. So you can see the forward database entries for prod, as well as the back to dev, as well as the dev forward database entries. And you can see there is the master, node 1 and node 2. So now that I have my forward database entries, my next step is really to create my self IPs. And this step here is actually quite simple. All you need to do is pull an address from that range. This is the pod network. It's not the Flannel cider as much as it's really the pod network in what we're going to create for our pods itself. And so this is somewhat where there potentially is some confusion that can sometimes arise with creating Flannel. So if you just follow my user guide, don't make too much modifications with regards to subnets and that kind of stuff, you will be successful. So with creating the self IPs, what I've done is on my dev cluster, I'm using a 10.244.0.x subnet, as you can see right here. And so what I did was, I just like to always use the same IP as the device, and I just use the /20 subnet. So I created my self IP right here, and on the prod side, it's similar range. The only difference is I've incremented it, because this is a different network, of course, 245 for the prod. So there is my tunnels and my self IP. So what's really important is you can actually go into the cluster itself. So this is .70. So what's really important here is to make sure that you can ping the BIG-IP. And so this is 244.20.60. And you can see I'm successful. So now I know that I have connectivity from my BIG-IP to from my Kubernetes cluster to my BIG-IP across the overlay. And you could actually do the same thing on the production cluster. Just increment the network 1, and you can see connectivity is working. You can also go back and ping from the BIG-IP. You could ping one of the pod networks that you deploy. Now you know that is the perfect way to know that we have connectivity. So going back, we are in really good shape. We've configured our vxlan tunnels. We've made our modifications to Flannel. We've configured our self IPs. Now I can actually go and deploy CIS as well as deploy IPAM and create these CRDs. And so this is the information for the node. We have to create these dummy nodes. Go ahead and read my user guide to get more information about the dummy nodes. The dummy nodes is really important because the dummy nodes really help the networking. You can actually see it if you do a kubectl get nodes. You can actually see that there are the dummy nodes. There's the prod dummy node, and then there'll be the same for the dev dummy nodes. And so if you follow the user guide, it explains. I have provided the link to the repo of the dummy nodes, so you could literally just clone the file and make the appropriate changes. And so here is what's important. This is the configuration of CIS for both dev and prod. And so what's important here is in the dev is to make sure that we're specifying the correct Flannel network. And I am using, you'll notice that the big IPs are both the same in both of the environments. I am also, in this case, I'm using a namespace. So you don't have to do this, but the reason why I created a namespace is that so that CIS is only watching the namespace dev or the namespace prod. This is namespace isolation. If you remove this, CIS will watch all namespaces in your Kubernetes cluster. I just added this to keep it very clean. You will see here's my partition as well. I am also adding an AS3 post delay. I'll talk a little bit about the post delay at the end of this demo. And the question is, why am I using the post delay? It's in this document as well. You can read a little bit about it. So as you can see, I've deployed CIS that is going to monitor my CRD and configure the big IP. The next thing that I wanted to do was configure IPAM. And why would I want to use IPAM? I want to use IPAM to simplify IP management so that the developer that is creating the application or creating the application using the CRD doesn't have to worry about getting a public IP. That user can just use labels, IPAM labels, and that's what I've done. I've configured my IPAM controller with a label, and my label in this case is called dev, and there is my range of IPs for the development network, and there is my range of IPs for my production network. And so I'm specifying these labels in the IPAM controller itself. And so if I go and click on the link, it will take me, and you can actually see it's a little bit small, but you can actually see there is the range. And that's all you need to do. Create this controller, and CIS and IPAM will communicate with each other when the CRD is created. And so that makes things a little bit more simpler when it comes to actually creating the resource definition. So let's go ahead and actually look at that resource definition, and we'll take a look at one of the examples right here. And so because I'm using IPAM label of dev that is tied to a specific host name, so that's really important. This is not service type load balancer. And so when I'm creating these IPAM labels, what I'm doing is I'm associating if you want to call it an A record, or I'm associating a public IP address to a host name. And the host name is what gets associated in IPAM to a specific IP address from the pool. And so in this case, my host name is dev.f5demo.com, and there is my label. And so what you could do is you could have dev1, dev2, dev3, etc., and just with that same label, and CIS will work with IPAM to continuously allocate a unique public IP for the specific CRD. And this is a virtual server CRD with health monitors and a backend application of F5 demo-dev. You will notice that I'm using the same namespace that I showed you earlier. And so you can go ahead and deploy this CRD, and it will get an IP address from IPAM. So let's go and do that. So if we take a look at the virtual server traffic, we're currently in prod. I'm going to change this to dev. If you notice, there's no configuration on there. We'll go to the dev cluster, and what we're also doing is we're watching the API. So as you can see, there is some APIs. I removed it before. What I'm going to do is I'm going to go ahead and recreate this. That's my CRD right there. So I will create this one. And you will notice right now, because I'm using post delay, I've told BIG-IP to buffer. And the reason why I'm doing the buffering is it's so that if there are multiple clusters talking to BIG-IP, that means that we can gather more configuration, buffer it, and actually scale the API a little bit more effective. So in this case, because this is dev, I'm scaling this to 30 seconds. What I'm doing is I am buffering all the changes, and within 30 seconds what I'll do is I'll gather all those changes and I will post it one time. And as you can see there, you've seen it. So I delayed the post, I gathered all the information, potentially all the changes, and I posted after 30 seconds. So it gives the BIG-IP some time to breathe. And this is really important for API scaling. And so that's what the post delay is really there for. And so maybe your production wouldn't, maybe you wouldn't use a 30-second post delay on production, maybe you use a slightly smaller one, or you wouldn't use a post delay on prod, maybe you only use the post delay specifically on some of the other, like maybe dev and stage configurations. You will also know that if BIG-IP is busy, specifically with the AS3 API, CIS will get a 503 back, and automatically post delay will kick in. And so there's really API scaling with post delay. And so let's go ahead and create the second configuration here. What we will do is we will create, this is the virtual server for prod. We'll go ahead and create this one. And you'll also notice that the post delay is going to kick in because that's what I configured. And again, you can make those changes as you need. And so let's go ahead and take a look at the BIG-IP. You'll see in the dev we have our virtual server that's been configured. If we take a look at our nodes, we can see our nodes are created and the nodes are up. So I know that the connectivity is working across that environment. If I want to hit the virtual server based on the on its host, I can do that. And so what's happening here is that I specified the host. There's no IP address in the CRD, but that's all being added by using the IPAM controller. As you can see, the second one is successful. And if I go back to the virtual IP and change it to the prod environment, you can see there's prod, there's the virtual IP. I can break this out if I want and take a look at a nice traffic map. There's a traffic map for that one, and I can connect to prod and connect it to prod. So you can kind of see how this works. BIG-IP connected directly to the pod, bypassing or not going through any kind of proxy. It's BIG-IP directly to pod across the multiple VNIs. And so that's the demo that I wanted to discuss today. And so let me go back to the diagram. And so what you've seen in the demo is BIG-IP working and ingressing traffic, specifically north-south traffic, for two Kubernetes clusters, one dev and one prod. The prod cluster is on a different Flannel network with a different VNI. We went through the different configurations that needs to be done for the Kubernetes cluster itself. Then we talked about creation of the tunnels as well as the self IPs. And then, of course, BIG-IP controller, IPAM controller, and then, of course, creation of the two CRDs. There is a little bit more to this, specifically with scaling the API. There's a lot of requirements. I have put links into best practices as well as talked a little bit more in the bottom of the diagram, in the bottom of the document specifically about API scaling. Thank you very much. If you have any questions, please let me know.